we need to work out. And then any other questions that you guys came up with, because I told you to look back through it and see what you're getting more practice with. So 16G. This one, guys, remember there was one on the test that was like sine of 2t over, I'm going to write sine now. It was like sine 3x over cosine 2x or something. And most of you bombed that question.
It's on the back page.
Yeah.
It was the first problem? Yeah, no,
Yeah.
I was going on that.
Which means I'm probably all the more likely to put that on your final. Because I want you to know how to do it, and so if you didn't do well the first time, I'm giving you another chance. So, you can expect to see something like this on your final, involving the division of a couple trig functions. But the thing here, when I see like the 3t and the 5t, that's my angle. So when I do this, this isn't sine of 3 times just a t. This 3t and the 5t, those are my arguments. So what rule am I going to have to use here? Chain rule. Okay, so start out with our quotient. Low, d high. Derivative of secant is? Secant tangent, and those angles would stay the same. But then, because my angle was not just a t, I have to do the chain rule. So what's the derivative of 3t? 3. Minus high d low, derivative of the bottom. Derivative of tangent is? Secant squared 5t times derivative of the inside. Derivative of 5t is 5. Over low squared. Right, as far as cleaning this up, there is very little you can do. I would appreciate it if you would pull coefficients out to the front, but that's really it.
What if we don't pull the coefficients? What if we just circle it?
Minus a half. That's what you get for being lazy and not wanting to rewrite it. So that would be our Well, I mean, I guess if you really wanted to be lazy, you could just erase that 3 and write it in the front, and erase that 5 and put it in front of that term.
I remember. Dude, you're the one, you know what? I don't remember.
How's that candy?
That's what I'm about to say. You just smacking it. You said
Okay. Let's look at that. Ew, that sounds ugly. I was feeling really nice. Okay, so what do we have to do here? You don't even know? Well, we can come up with something.
Well, I did like 5/3 and broke it up and put the top side.
You can change it to the top and bottom.
Yeah.
And that would work. And then you're going to do the quotient rule with the chain rule. Or we could just start by doing the derivative of a power and do our chain rule within that. So either way, we're going to do the same steps. So if we just write down the 5/3, inside stays the same. Subtract 1 from the power times derivative of the inside. So to do the derivative of the inside, we have to do the quotient rule. So that's low. D high, what's the derivative of e to the x? E to the x. Minus high. D low, derivative of 1 plus x squared. 2. Over low squared. All right, You don't just circle it. We can clean this up a little bit.
Alright, how many points would we miss if we
Yeah,
circled
that's what
it?
Cass did. He circled it.
So our denominator, we have a 5 on top, a 3 on the bottom. Okay? This is 1 plus x squared to the 2/3 and 1 plus x squared squared. So if you multiply those, you would add the exponents. So 2/3 plus 2 would be 8/3. On the top, let's pull out that e to the x. So if I pulled out that e to the x, that's an e to the x, and then we have an e to the x to the 2/3. Which totally lost you. So, okay, this would be like e to the 2/3 x. If we took out this e to the x, then when you multiply those, you would add their exponents. So 2/3 x plus 1x would be 5/3 x, and then the 1 plus x squared minus 2x. That one, I may not count it wrong if you don't do all of that, but it would sure make me happy.
Bonus points.
I probably wouldn't even know what this works, honestly.
But if we simplify and we get it wrong, then
Exactly.
we end up missing like points when we could take the risk that you don't minus points if you just block
And
it.
not that you said that, you put minus points.
Just all, that's a good game theory question. Game theory was like my favorite class that I ever took. And it was all about just problems like that, is it better to go further and risk getting it wrong, or to stop where you are and risk getting points taken off? I mean, I love that class. It was awesome.
Oh, I did not, because I'd be sitting there overthinking it.
Oh, I mean, that's all it was. There was
Oh, I couldn't. I do that
And-
too much on my own.
Yeah, and he is actually one of my graduate classes, and he. Okay, so 18, implicit differentiation. Okay, so on the left, when I have a cosine x and a sine y, what am I going to have to do?
Oh,
All right,
what happens if you did 4?
oh, that's fine.
Okay.
Okay. So, derivative of the first. What's the derivative of 4 cosine x? 4 is just coefficient, it stays. What's the derivative of cosine? So it becomes negative 4 sine x times the second, bless you, plus the first. Derivative of the second. Derivative of sine is angle stays the same, but anytime you do the derivative of a y, it gets should it be 0? Yes. Derivative of 1 is 0. So we can add that term over. And then if you divide by the 4 cosine x cosine y, dy dx equals, the 4's cancel. You could leave it as sine x sine y over cosine x cosine y. No, I actually did.
What were you gonna say though?
If you have sine x over cosine x, what's that turn into? And sine y over cosine y?
Tangent again.
Yeah, so you could write it as
Oh.
tangent x, tangent y also. Either way.
No, wait. I really flipped those in my mind. I don't know why.
That'd be different. I wouldn't ask the same question twice.
I know.
Is that one good? and B. So we have to do the product rule on each side. Derivative of the first. You could,
Oh, you can.
and you'll end up doing the product rule
But is
still.
that
'Cause
longer?
maybe one step longer, not
Okay.
much. So derivative of the first would be 4x cubed times the second plus the first. Derivative of the second. What's the derivative of x plus y? Equals. Alright, derivative of the first. Derivative of y squared would be 2y dy dx times the second plus the first. Derivative of the second would be okay. So now it's kind of a mess. Now we're going to multiply it all out. So we get 4x to the fourth plus 4x cubed y 6x to the fourth plus x to the fourth dy dx equals 6xy dy dx minus 2y squared dy dx plus 3y squared minus y squared dy dx. What do we do with this mess? No, do not box it in. Okay, everything with the dy dx on one side and everything without it on the other. I will just move this one over to that side, and then this 3y squared would have to come over here. So you get 4x to the fourth plus 4x cubed y. I can combine some like terms, can't I? 4x to the fourth and 1x to the fourth would be 5x to the fourth. And then if I subtract over my 3y squared equals, okay, we have 6xy dy dx. Negative 2y squared and negative y squared would be negative 3y squared dy dx minus x to the fourth dy dx. Then what do you do?
Take out that dy dx.
Can I do this in one step where I pull it out and divide all that stuff over? Questions? Okay. So those are all the questions from the study guide that we hadn't worked. This is dangerous though, because you actually would like for them to work out, wouldn't you? Let's not do it. Okay. What should you always check first on these limit questions? If you can plug it in, because I'll probably give you one where you can't. You can plug it in legally as long as you're not getting something that's undefined. So if I just put this one in though, I'm getting 0 on the bottom, so we can't do that. When we have radicals, what's our strategy? Conjugate. So I'm going to multiply by the square root of 9 plus b plus 3 on top and bottom. So square root of 9 plus t times the square root of 9 plus t is just 9 plus t. Since they're conjugates, the outside and inside would cancel, minus 9. On the bottom, I am not going to distribute because my goal is for things to drop out. What happens on the top? The 9's cancel. T's cancel, just leaves us with the 1 on top, and now we can plug in. So we get 1 over the square root of 9 plus 0 plus 3. So 1/6. Let's do another one. I said the limit What would you do here? We check, we can't just plug in because the bottom's 0, so if we factor the top, that factors into x minus 3, x plus 1, or x minus 3. So then the x minus 3 is dropped, and you can plug it in, 3 plus 1 is 4. Can I just plug in? 1 minus 1 is 0, so we can't. What would you do? Okay, so we always see if anything would cancel when we factor. So on the top we can take out an x, that leaves us with an x plus 2 over x minus 1. So we're not in very good shape here because it still doesn't cancel. However, a good indicator, when I give you these left and right hand limits, it's probably an indicator that we can reason through this. Okay? I know if I plug in the top, I get 1 times 1 plus 2 is 3. On the bottom, 1 minus 1 is 0. But you are approaching from the left, so you are putting in something smaller than 1. So something smaller than 1 minus 1, would that be positive or negative? Negative. So you have 3 over a smaller and smaller negative number. So that would be. So a lot of times those left and right hand limits, not always, I might give you one where you can still just plug in. But if things don't cancel out, you can reason through it. Let's do one more. Limit as theta approaches 0, 1 minus cosine theta over what do we do? Multiply by the conjugate. So that gives us 1 minus cosine squared over theta times 1 plus cosine theta. How does that help me? times n. I have 1 theta. What we know is if theta is approaching 0, sine theta over theta goes to 1. This would go to sine of 0 is 0 over 1 plus cosine of 0 is 1. So we get 1 times 0, which is 0. So we've hit the limits pretty hard. What else do we need to review? Okay. So I could ask this a couple different ways. There was one on the study guide where I said use the intermediate value theorem to show that this has a solution, but I didn't give you an interval. This time I gave you an interval, but I'm still just asking you to prove that it has a solution. I should probably say by the intermediate value theorem if I were asking you to use that on the test. I would tell you what I wanted you to use because there are a couple of different ways we could actually prove this. First of all, if the intermediate value theorem works, what kind of function does it have to be? Continuous. So we know x squared plus 2x, that's a polynomial, so it's continuous. Then, what we had to do is plug in 2 points. One of them to give us a positive answer, one of them to give us a negative answer. Since I gave you the interval, those are the 2 numbers you plug in. If I didn't, you just have to come up with 2. If I plug in a negative 1 cubed plus 2 times negative 1 is negative 3. If I plug in a positive 1, we get positive 3. And then you have to write me a little conclusion. So since the sign changed, so we have a continuous function and there's no breaks in the graph. So the only way it can go from a negative to a positive is if it crosses 0. Between those 2 x values. So what you need to understand is a derivative represents a rate of change. So if I said, let's say V is the volume of something, volume of a puddle, and T is time, then if I said, let's say V equals F of T, so that tells you the volume is a function of time. And if I ask you to interpret, if I said F prime of 6 equals 3. Let's say this is time in minutes. And let's say this is the volume in cubic centimeters. All right. So you would have to be able to write a sentence. First of all, what does the 6 represent?
6.
Mm-hmm. So after 6 minutes, F prime. So F is talking about volume. Derivative is a rate of change. It's not what the volume is, it's how the volume is changing. Because this is positive, is the volume increasing or decreasing? So the volume is increasing. Three cubic centimeters per minute. Volume is or derivative is a rate of change. So it's something per something when you're giving me units.
Will you give us an equation for like what to use if you give us a problem like number 5 with this or what to
If I were talking about volume of a sphere, I would give you that. Now, some things I would expect you to know, like area of a rectangle or area of a circle. What is area of a circle? Oh, you do.
Like 1/2 pi something.
What else? Gradient?
Pi r squared.
R squared.
Yes.
Okay.
Yes. We should know area of a circle. Pi r squared. What's area of a rectangle?
Half.
Rectangle.
It's like, yeah, it's like.
Oh,
it's like
rectangle, shoot. Okay, sorry.
Times the size.
Length
Times
times
width.
width.
Can't find the words. I knew what it was.
Nothing to be concerned about. Okay.
Calculation thing, like, calculate your grade, what you need to get on the test to keep an A.
You make it 94.
All right. What else? Do you guys remember how to do the infinite limits? I didn't do one of those, but like problem E, 7E.
Yeah, definitely need that.
Oh, it's all zero.
So if I asked you to evaluate limit as x approaches, let's say negative infinity of 5x. I can't just plug in because I get infinity over infinity and I don't know what that is. So what would we do?
Times 1/x4.
So that would give me a limit. So x approaches negative infinity. A 5 plus 3/x squared plus 1/x cubed over 2 plus 3/x plus 4/x to the 4th. Now, a number over infinity is going to turn into what? 0. So you get 5 plus 0 plus 0 over 2 plus 0 plus 0. So our answer is 5/2. What if I asked you to find I asked you to find the equation of the tangent line at a particular point. What information do you need to find the equation of a line?
Slope.
Point and a slope. I gave you the point, we need the slope. How do we find the slope of this? Derivative. Slope of a tangent line is derivative. So we have to do quotient rule. So low d high minus high d low over low squared. So then we need to get our actual slope, we have to plug in our x. Our x was 1. So 2 minus 1 is 1, squared is 1, so the slope is negative 6. So now we can plug into the derivative, or the y equals mx plus b. So y is 3 equals m times x plus b. So our b is 9. So our equation is y equals negative 6x plus 9.
Is it supposed to rain today?
That's very off topic.
I know.
I don't know. Okay, what if I said the position of an object is given by the equation S equals and I asked you to find the average velocity over the time interval 1 to 3. If I ask for velocity in general, how do you get velocity from position? Velocity is just the first derivative. But when I ask for average velocity, that's the slope, average rate of change. So we have to find the slope. I have given you 2 times, 1 and 3. What do I need to do? Plug those in to my S equation. So those are my times. So if I put in a 1, I get 1 plus 3 plus 1, which is 5. If I put in a 3, I get 1 plus 9 plus 9, which is 19. And then we just need the slope between y sub 2 minus y sub 1, or x sub 2 minus x sub 1. So my average velocity is 7. So you have to know the difference between instantaneous velocity, which is derivative, or average velocity, which is just slope.
What was the first one?
Instantaneous. That's just velocity at one particular point. So then you would do the derivative. What about definition of derivative? Do we need to do one of those? What is the definition of derivative?
A plus h minus x plus.
You can do either f of x plus h or f of a plus h. They are going to be the same. So we limit as h approaches 0. F of x plus h, that means I go to my function and replace my x with an x plus h minus f of x over h. Alright, so for this, x plus h squared, that means you have to write it twice and FOIL it. Distribute my negative. So I get 2 minus 4x squared minus 8xh squared minus 2 plus the 4x squared. And what happens? 2's cancel, 4x squareds cancel. Everything left is divisible by an h, which should work out if you've done your work correctly. So you get negative x minus 4h. Plug in a 0 for your h. My answer is negative 8x. Which we could quickly check. If I just asked you to do the derivative of this using power rule, you get 0 minus 8x, which is negative 8x. We have about 5 minutes. Anything else? You'll have implicit differentiation, you'll have derivative with trig function. I know we kind of worked those out today.
Well, like D, 16D.
Okay. So this is just asking us for the derivative, and we can do it term by term. We can do the derivative of the first one plus the derivative of the second one. To do the derivative of each of these things, what do we have to do? Quotient rule. So low, d high, what's the derivative of the top? 1 minus high, d low, derivative of the bottom? 1 over low squared. Same thing over here. Low, d high, derivative of the top is 5, minus high, d low, derivative of the bottom is 1, the bottom squared. If you just box this in, you're losing points. You can multiply this out. X times 1 is x minus 3. Over here I get 5x minus 20 minus 5x. So combine like terms, you get negative 3 over x squared plus negative 20 over x minus 4 squared. Alright, so this, the big thing we would have to do is product rule. So derivative of the first. So for this first part, the 4 would come down. Inside stays the same. Subtract from the power. But am I done with that derivative? Derivative of the inside, which would be 3 plus 3x squared. So that's all the derivative of the first times the second one plus the first times derivative of the second one. So the 2 comes down, inside stays the same, subtract 1 from the power times derivative of the inside, which is 2x. Are you done? No. At the very, very least, I would expect you to multiply this 2 times the 2x and put a 4x.